Right, guys, we are starting a new topic called acids and alkalis. So, this topic is actually in the year 7 Activate book. And last year, you did not do this topic. Okay, so the topic title is acids and alkalis. It will take approximately 4 lessons. It's not that long, so we should fly through it quite quickly. So, what we are going to cover today is what are acids and alkalis? And we are going to look at hazard symbols. The following lesson will be on indicators and the pH scale, then on neutralization, which we will take 2 lessons on. Okay, and that will be the end of the acids and alkalis topic. Now, you will have to go and find the Activate One book. It is on Google Classroom as a PDF doc in classwork. Also, you can find it on Caboodle, where you can find the Activate One book and the Activate Two book. Okay, so it's in 2 places. So let's start. So acids are a group of chemicals. What do we know about acids? Are all acids dangerous? So think about that statement there. So, do you know of any acids? If you do know of any acids, are those acids dangerous? And can we get acids that aren't dangerous? So think about that for a moment. Now, here we've got a picture of a person who is fully covered up in protective clothing, and we've got several vegetables and items on the actual table. Now, if you have a look at some of these items, do some of these stand out as acids? If so, which ones do you think they are? So have a few moments, pause the video, see what you can think of. What do you think has got an acid in it? Whether it's a strong acid, weak acid, just think about that for a moment. Now, here are a group of chemicals. On the left hand side, there are things that we find in food. On the right hand side, there are what we find in a chemistry lab. So on the left hand side, we have got lemons, oranges, and vinegar. These all contain acids. On the right hand side, we've got sulfuric, hydrochloric, and nitric acid, diluted hydrochloric, nitric, and sulfuric acid. So we can get acids in a lab and we can get acids in food. So, can you think of any other examples of acids? So, the next thing that we're going to look at is weak acids. So, acids, you can find them in household items such as food, drinks, or beauty or skincare products. Here are some pictures of items that have acid in them. Some have different types of acid. Some are strong, some are weak. So here are some examples of where we have weak acids. Okay, so using these items is not going to cause you any considerable harm. So what's a strong acid? So nitric acid, hydrochloric acid, sulfuric acid. These are acids that we use in the lab and they are corrosive. Okay. Some of these acids can be found in car batteries, and that's why we don't mess around with opening up car batteries, because that liquid inside a car battery is very corrosive, and there are strong acids inside there. So we must handle these very carefully. So they are very dangerous to even taste or touch. Weak acids, you can taste or touch them and they won't cause you considerable harm. So an alkali, so here are some examples of an alkali. You got soap, very liquid, toothpaste. All of these contain alkalis. Sodium hydroxide is an alkali. Ammonium hydroxide is also an alkali. And these are used in a lab, and these are general used at home. Okay, and these are opposite to an alkali acid. And on the left, you've got everyday alkalis. On the right, you've got the ones that are in the lab. So here are some other examples included for alkalis, and these are examples of weak alkalis. So they feel soapy and they are safe to handle. So here are some examples. Cleaning products are strong alkalis. Ammonium hydroxide, sodium hydroxide are used in the lab are also strong alkalis. Fortunately, these are too dangerous to touch. You wouldn't really want to continue to work with cleaning products with direct contact with your skin for long periods of time, because that could cause a lot of damage. Okay, these alkalis are said to be caustic because they can burn skin and damage other materials. So they are strong alkalis, and that's why they should be handled very carefully. Okay, so moving on, just before we move on, what I would like you to do as an extra is find the acids, the specific acid that's in everyday alkalis, find the chemical symbol for each of those acids, including sodium let's go back. Where are we? So find the type of acid that's in lemons, in oranges, in vinegar, in lotions such as Nivea lotion if you can, and find the chemical symbol for those acids. Equally, can you find out the chemical symbols for these acids? And once you've found and written down those chemical symbols for these acids, can you tell me what you notice as a similarity between all of those chemical symbols? Equally, I would like you to find the alkali that's in fairy liquid, toothpaste, soap, the chemical symbol of sodium hydroxide, ammonium hydroxide, and the chemical symbols for what I've just asked you for these. So what I would like you to do is see if you can spot any similarities between the chemicals which are present in an alkali. That task should take you no longer than 10 to 15 minutes. The second part of this lesson, we're looking at hazard symbols. So here are some hazard symbols, and they have changed. Some of these pictures have changed, and your worksheet has those changes in there. So some of them haven't. So here are some hazard symbols. The first one, the skull and the cross bow, we've got that's as toxic. The irritant and harmful symbol are very similar. These two are the symbols that have changed. Corrosive, okay, this is a chemical symbol for corrosive, and that's the chemical symbol for highly flammable. There are a few more chemical symbols, and what I would like you to do is use the internet for the hazard symbols task to find out exactly what those symbols are and what they mean. So, what are they for? And the reason why we have chemical symbols is to recognize the type of hazard that chemical may pose. So, you may have a bottle, it may have one of these symbols on it. Just by looking at that symbol, you know what safety precautions you must take in order to avoid any harm to yourself. So by looking at these symbols, we can clearly see whether you should be wearing gloves, goggles, more protective equipment, knowing whether if this liquid spills, is it going to be corrosive? Is it, if there was a flame nearby, is it going to set alight, etc., etc. So what I would like you to do now is find out what these chemical symbols mean, and that is a task on one of the task sheets. And complete those two task sheets in addition to the task I set you on in the previous slides. I've asked you to find the chemical symbols. That should take you no longer than about half an hour.